Hi everyone, welcome back to my YouTube channel. In this video, we are going to look at the last part of coordinate geometry, where we are going to be looking at another exam example from one of the previous question papers. In this question, we are told that the quadrilateral ABCD has vertices A, B, C, and D, and A, B, and C you're given the coordinates as indicated there. Now in A, make sure, again I'm emphasizing, reading to understand your questions. Make sure you understand everything that you're told so that you can use the information that you're provided with to get the correct response to these questions. So in A they said, find the midpoint of AB. So it means we are looking at these 2 points because this is A and B. So what are we going to do? We are going to say that we know by now that to get the midpoint, we add the x coordinate. So we'll say 2 plus negative 6, and that we divide it by 2 to get the x coordinate, and the y coordinate we are going to add the y's, so it's y, which is 3 plus 9 divided by 2, and that gives us 2 plus negative 6 is negative 4 divided by 2, and 3 plus 9 is 12 divided by 2. So if we simplify this, we have our midpoint will be negative 2 and positive 6. So that is our midpoint of AB. We add the x coordinates, divide by 2. Don't forget the signs. If it's negative 6, you use it as negative 6. You don't go and use it as 6. You're going to be wrong. And then 3 plus 9 divided by 2, giving us 12 divided by 2, which is going to simplify to 6. So that is the coordinate of the midpoint of AB. The next question needs us to calculate the length of AB. We've looked at these formulas in the first video, so now we are going to go ahead and just find our length of line AB. If we recall carefully, or we try to remember, the formula that we use to find the length, which is also the distance AB, is going to be, we find the difference between the x's, like x2 minus x1 squared plus y2 minus y1 squared. So that is exactly what we're going to do. It doesn't matter which one you call your x1, y1, x2, y2, or it could have been that this is x2, y2, and x1, y1. Doesn't really matter which one you call which point, but you just have to be you don't mix them up. So here, to find the length, we're going to say, okay, let's call the A as point 2, or let's just, because it's A and B, we can call B as if it's our point 2. So we'll say negative 6 minus 2, that we have to square, plus 9 minus 3 squared, and remember that all this should be square rooted. So don't forget to square root it. So negative 6 minus 2 is this. It's going to simplify to negative 8 squared. Don't forget to put it in brackets. Plus 9 minus 3 is 6 squared. Square root of that. And what is 8? Negative 8 squared is 64 plus 36, because 6 squared is 36, and 64 plus 36 is going to give us square root of 100, and square root of 100 is going to give us 10. So we'll say 10 units because it's length. So we just say unit. We don't know whether it's centimeters or kilometers or meters, so we just call it units. So we are going to continue with C, and remember, the moment you see that they're speaking about parallel lines, you should know that they have the same gradient. So since you don't know anything about D, and you only know for CD, you only know the point C, then it's not enough to find the gradient CD. So you will use, to get the equation of CD, you will use the gradient of AB. So we are going to take AB, and I'm going to solve it here. So we are going to solve C here. So to get the gradient of AB, you can decide which one you want to call your your x1 and y1, which one you want to call your x2 and y2. Let's call B as if it's our second point, meaning it has x2 and y2. So it means then the gradient of AB, if we want the gradient of AB, it will be change in y, remember change in y over change in x, so it's 9 minus 3 over change in x, negative 6 minus 2. And what is that? That is 6 divided by negative 8. And what is that? That is negative 3 over 4. So we know the gradient, therefore this is telling us that the gradient of CD is also going to be negative 3 over 4, and we know the point C, which is 1, 5. So here, now we have found the gradient of CD, and we took it from AB. Remember, we were told that the two lines were parallel, so that is a hint that they have the same gradient, as we have learned in the first video. Now, what else do we know about this line that we are trying to find the equation of, about line CD? We also know the coordinate C, which is 1 and 5. So this is where the part in the syllabus which says you should be able to find the equation of a straight line given sufficient information. So now that we have this sufficient information, where we have the gradient as well as a point on that line, we are going to be able to find the equation. How do we find this equation? You have two formulas that you can use to find this equation. One, you can say that y minus y1 is equal to mx minus x1. X and y are variables, they will remain x and y, while x1 and y1 are going to be coordinates of the point that is part of the line you're trying to find the equation of, meaning, like in this case, point C. So this is our x1 and this is our y1. So what do we do with that information? We come and do our substitution. So what do we have? So y will remain y, y1 is 5, equal to m, which we got is negative 3 over 4, and we have x, which will remain x, minus x1, which is 1, close the bracket. What does that give us? It gives us y minus 5 equal to negative 3 over 4 times x is negative 3 over 4x, plus, because negative times negative is positive, so negative 3 over 4 times negative 1 is just a positive 3 over 4, plus 5. To remove it from there, we come and add it to its like term here, plus 5. So, and we're not only adding it to 3, we are adding it to the whole fraction. Please take note of that. We are adding it to this whole fraction, plus 5. So, to simplify that, what do we get? We have y here equal to negative 3 over 4x. And then 3 over 4 plus 5 will give us a positive 23 over 4. So with that said, this is our equation. And they could try and challenge you and say, perhaps give, so they could say, give your equation in the form ax plus by plus c equal to 0. If that is what they said, then we were just going to multiply everything by 4, multiply that by 4, every term by 4 too. It's like you just want to remove these fractions. So times 4, and that will give you 4y, and then equal to, we are relating back to that, if you times by 4, then it's just negative 3x, and then we have plus 23, and what is that? If we are to arrange it in this way, then we bring the 3x over, it becomes positive, plus 4y, we want to arrange it in this form. They can ask you to arrange it in this form, and we should be able to do that. So we 3x plus 4y, and then we bring the 23 over, it becomes negative, so we have that equal to 0. So this is what we would be doing if we were asked to write it in this form. But they have not given that instruction, so whether you write it like this or you write it like that, you get your full marks. But if they have instructed you to write it in this form, then you should. I just went further to explain that. Now, what is another way that you could have used, or another formula that I was talking about at the beginning of the video, or at the beginning of the solution to this question? So I was saying you can also use another equation. So alternatively, you can also use the equation y is equal to mx plus c. We know that when we have an equation y equal to mx plus c, this is the standard equation of a straight line. So if I know the gradient and I also know a point, so this is like my x and my y, I don't have to call it 1, or I just have to call it x and y for this part of this for this method, for this formula. So I'll say y is 5, and then I have m, which is negative 3 over 4, x, which is 1, as in point C, plus c. So I'm just using this point, which is on the line that is coming from the equation that I'm trying to find. So what is this? This is 5 equal to negative 3 over 4 times 1 is just negative 3 over 4 plus c. So if I add 3 over 4 to the other side, I get a positive 23 over 4 equal to c. So I see that c is positive 23 over 4. Now that I know what my gradient is, and I also know what c is, which is the y-intercept, I can therefore confidently say that my equation will be y equal to m, which I found already to be negative 3 over 4x, mx, plus c, which I found to be 23 over 4. And if I wanted to put it in this form, I would have just continued, or if the question needed me to put it in that form, I would have just continued like this to rearrange it, remove the denominators, and arrange it in the form that they want me to give it as. So, but because we were not given that instruction, we didn't have to do that. Okay, so that is how you're supposed to solve or find the equation of this line. So we have solved C. Now we are going to continue with D. Now, what does D want us to find? They said that the equation of BD, so we're solving D, and they said BD, so what do we know? We know that BD is equal to negative 2x minus 3. Now they said line CD and line BD intersects at point D. So let's go back a bit just to understand what they're saying. So they're saying that line BD and line CD is indicated, so we can see there line BD. So it's more like if they intersect, if they meet at point, so they're saying line CD. What is line CD again? We found the equation of line CD, we just found it. What did we find it as? We found it as negative 3 over 4x plus 23 over 4. So they are saying that these two equations, they meet at D. These two lines meet at D. So now they want us to find, so here they said the line CD and line BD intersects at point D. So now we need to find the coordinates of the point D, where the two lines meet. Very important, if you are asked where the two lines meet, it means the point of intersection. These two lines will meet where they are equal. But if you are to simplify these equations, this line BD, let's write it in the proper way of a function. It's y equal to negative 2x minus 3 as given in the question. And this is also y is equal to negative 3 over 4x plus 23 over 4. So these are the two equations that I'm trying to solve. So where do they meet? Where do they intersect? They intersect where they are equal. So basically, you are solving these two equations simultaneously. So if I have y is equal to negative 2x minus 3 and y is equal to negative 3 over 4x plus 23 over 4, then it's fair to say that since the two equations are both equal to y, and I know for a fact y is indeed equal to y, right? So these two are equal, right? So if y is equal to y, then it's fair to say the two equations are also going to be equal since they are equal to two things that are equal. I hope that makes sense. So if I'm saying that these two equations are both equal to y, then it's fair to say that they should also be equal to each other because they are both equal to y. So what do I do then? I just have to group the like terms. So it means I'll say negative 2x plus, because when 3 over 4x comes over, it becomes positive, plus 3 over 4x equal to 23 over 4 plus 3, right? So you can press on your calculator, negative 2 plus 3 over 4, get the answer. It will give you negative 5 over 4x. I got negative 5 over 4x equal to, and 23 over 4 plus 3, I have 35 over 4, right? So now you can choose from here. You can divide both sides by negative 5 over 4, or you can first times both sides by 4, and if I remove, it's a fact that if I multiply a fraction by its denominator, then it goes, and since it's the same on the other side, it also goes on the other side. So what do I have left? I have negative 5x is equal to 35, right? That, then it means I must divide both sides by negative 5, both sides by negative 5, and if I divide both sides by negative 5, I get that x is equal to a negative 7. And since I know x, I can use one of these equations to find y. So to get y, this is what you will do. Since I know I can use y, you just choose the one that you're bonding the most with. You don't have to use this one. You could have used that as well. But just use one that is safe, and you can, if you have time, you can always confirm with the other one. So I want to know y. It's not enough to just find x. Remember, it's a coordinate. So it should have x. So I'll say x is negative 7. But I should also find y. So that is why I'm coming to use the x that I found so that I can establish or find what the y for this x would be. So it means I'll have negative 2 here, and then x we said is negative 7, and then we say minus 3, right? So what is that? That is y equal to a positive 14 minus 3, which means y is 11. My coordinates will be negative 7, 11. Okay, so that is how. Just take note that when they speak of point of intersection, and then you have your two equations, or even if you didn't have both, but they spoke about a point of intersection, then it makes sense to actually find where the two equations are equal, meaning you're solving these two equations simultaneously. If you didn't have one of the equations, you would find it. There must be a way to find that equation so that you can actually solve them simultaneously, or rather make them equal to each other. So, and this is more or less just what you are expecting to get under these topics. So with all that, remember, with all that, if you have mastered and understood this, and if you didn't, you can always repeat the video and pause the video, and you try again until you have the formula by heart. You are able to read your question and interpret what they're actually asking you to do, and that will mean that for this topic, if it comes, you're getting your 4 marks. And imagine if you were to look at this question, this is already 6 marks here. So this is already, if you look at this is already 3 marks. So that is already 6 marks, 7, 8, 9, 10. That is already 10 marks just in one paper on one topic. So this is a lot of marks that you can actually obtain if you get a question like this in your exam. So all the best with this topic. I do hope that you have mastered, and that if you have practiced enough, and you can always go back and start from the beginning again, and just make sure you have it. You got this. All the best.